Okay. I will call this determining the true region for an inequality. Okay. And this is the shortcut. No test point required. So up until now, we used our test points to figure out where the true or where the false region is. But our main objective is to find the true region. That's really what we're after. Okay? So determining the true region for an inequality, shortcut, no test point required. Okay? So we need to rewrite the inequality into y equal to mx plus b. So I'm using equals there, and this is a shortcut that I just came up with, so the textbook won't really have this, but it is very helpful to work with. So you wanna rewrite it in this form, and then you can tell what's happening. So if you get y is less than or y is less than or equal to, right? When you have it like this, then we know true region is above line. Okay. Sorry, I'm looking at my notes and I'm doing it backwards. Is below. Can we change the above to below? My bad. I apologize. That's what happens when you go off script. Okay. So the true region is below. So if it's less than, then the true region is below the line. And I'll give you an example here, just nothing fancy, okay? Don't make this too fancy, it's just so you know. I'm going to give you 3 different examples. I'm going to use a different color here for that, for the line. So you could have, of course, a line that goes up, right? And this happens to be solid. Okay, I'm just going to mix it up, give you a bunch of examples. You could have a line that points down and it's dashed. And last but not least, you could have just a plain horizontal line. And I'll make it solid as well. These are your 3 different scenarios. Okay, so in each one of these, once you determine the boundary line, when you see less than, then you know that the true is below. So true You look at this line, and this is below right here, so the true is here. And on this horizontal line, the true region would also be below. So no matter which way it's pointing, it's always below the line. So we would shade just lightly everything that's below it. So without using a test point, you can still use the test point. If you like that method, go for it. But when you do systems, folks, it's going to confuse you, and it's going to take a lot longer. Okay. And so if you have y is greater than, or y is greater than or equal to, then it's the exact opposite, right? True region is above. Maybe I'll capitalize that too. True is above line. So I'll say here, true is below, true is above. And think of greater, right? Y is greater, so above, right? This one, you always read it from left to right. Y is less than, so it's below. Okay. So let's make 3 little grids again. And I'll mix it up. It will not be the same as up there. So let's say our first one is a solid. Let's make it go over here somewhere. Okay. We'll have one dashed line going here. And let's make a dashed line as our horizontal again. And in this case, you would say that the true region is above for every single one of them. And therefore, the other region is false. Okay, guys? It's just assumed, but we're focusing on the true region here more than anything. So we're going to shade everything above. That's, of course, using regular shading. So this is basically a summary of how we shade. And then I'll show you the special cases, which is the X. When it's just X, then you have a vertical line, right? How about this? I will just add that this is just Y would be, in this case, less than or equal to a number, right? In that case. Here, Y would be greater than a number. That's all you have. You don't have an X variable. And you remember why just go greater than and not equal to? Because a dashed line, right, means that it's just greater than. Okay, nothing else. So special cases. If you ever encounter one of these, I already did these ones as well on the previous couple of lines, but I just want to have them all here. These are my special cases. So I'm going to make four different grids. So if it's these are horizontal lines, right? So anywhere, let's make them all dashed. And just put them anywhere, it doesn't matter, but they're going to be horizontal lines, and that all depends on what the number is. Verticals, let's put one on the left side of the y-axis, and let's place one on the so again, when y is greater than the number, where is the true region? Y is greater than above, right? True is here. Y is less than a number, true is below. What about just x? If x is greater than, where, common sense, where would you say the true region would be if it's greater than the number? Right or left? Right? It's right, right? Okay, I'm play of words there, right? But yes, it's true here. And this one is left, right? No, I'm just kidding. Now you're all confused. Yeah. So let's just shade in. Once you determine the true region, everything else is piece of cake. And I'll just make a note here, right? These two, those are horizontal lines, right? No diagonals. And these two are vertical. Vertical lines. Right? And I will make a note down here. Note lines can also be solid if or are used, are present. So don't think, oh, Mr. Dirksen put dashed lines, it's always going to be dashed. No, it could be solid if the symbols had included an equal sign as well. good. Also, if an inequality has this or this, right, less than or greater than, right, the points on the line are not part of the solution. Okay? If an inequality, I'm just going to do IQ here, has, or that means that the points on the line are part of the solution. It's very important to remember. So a dashed line means, hey, this is the boundary here, but the points on it are not really included. Okay, it's everything has to be within the shaded region. Okay. And another point here, to check if a point is part of the solution, i.e. is found in the true region. That's what part of the solution is, right? You would be located in the true region if you were to graph it, right? Plug in point into inequality or inequalities. If there are more, you would just have to plug them into all the inequalities. And see if statement is true. Example. If you have an inequality, let's say it's negative 3x plus 2y is greater than or equal to 10, right? And you're asked, is negative 3, 4 part of the solution? And that's just a short of writing solution. So you've given an inequality, hey, would that be a solution? Because remember, inequality, you don't have just one solution, right? You have a bunch of solutions, like it's all the shaded region, right? So let's see if this were to work. So let's plug that in. This is my x, that's my y, right? So we go negative 3, x of this point happens to be negative as well, plus 2y, and y is 4. Is that greater than or equal to 10? Okay? 3 times 3 is 9, plus 8 is that. 9 and 8 is 17. Is that statement true? Yes. This is true. Therefore, negative 3, 4 is a solution. So there's no graph, so you can't look at the graph and just determine it. You actually have to just plug it in and go. Okay, so that's so funny. You gotta share the joke if you're laughing. That's the rule here. Okay. So A, you have 6x plus 5y is less than negative 10. And I'll just do a couple real quick before we go into systems. So if you wanted to graph this, I would recommend you can find the x-intercepts just like you did before. So let's do that. X and y intercepts. So x-intercept y is equal to 0. So this ends up being 6x is equal to negative 10. Divide both sides by 6. You end up with negative 5 over 2, which is really negative, no, sorry, 5 over 3. We'll just leave it at that. Or that would be 1.67, right? So we can do that, negative 1.670 for our x-intercept. And the y-intercept, we have 5y is equal to negative 10. Divide both sides by 5. Y is equal to negative 2. You have 0, negative 2. You have your intercept. So that's, in my opinion, if you want to be successful later on, this is a must here to find the intercepts real quick. Let's rewrite this. 5y is less than negative 6x minus 10. So the 6x came over subtracting. I divide everything by 5. I'm not dividing by negative, so I don't need to worry about flipping the sign. Remember that? I hope you remember that. So this is negative 6 over 5x minus 2. What do I know about this? Right off the bat, I know that because of this, I know that the line is dashed, correct? And true is where? Y is less than. Now you can just look at that and say true is below, right? Is below line, okay? After a while, I'm just going to say true is below, that's it, right? But that way you know. So in rewriting, you came up with what the line is supposed to look like and where the true region is. So let's go do this. Shouldn't take that long. X and Y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is down here. 1, 2, 3, 4, 5. That's good. So negative 1.67 is right about there. 0, negative 2 is there. Use a dashed line. Don't forget to label right away. Right, I labeled right away. And for now, I'm going to actually label the true region, which is below. And I'm going to shade it. Let's see if you were paying attention. Is 0, -2 part of the solution? 0, -2, is it part of the solution? The answer is no, right? Why is it not part of the solution? It's a dashed line. The line points on the line are not part of the solution. That's the first answer. Another answer would be try to plug this into the inequality. It will be false, right? If you plug in this into your inequality, you will get a false answer. So there's two ways of checking whether or not it's part of the solution. One more. Let's see if you can handle this one. Just by observation, you should be able to tell. It may look a little intimidating, but what's missing here? What? There is no x variable, right? So what is my line expected to be? Horizontal line, right? It's just y, right? So right away, I'm like, okay, I got this. So the 1/3, we're going to get rid of it. So you multiply this side by 3 and that side by 3. You multiply both of them by 3. That gets rid of this. So you really end up just with y plus 6. And on the, not equal sign, it's just a less than. 4 times 3 is 12. In terms of the arithmetic, you treat it like an equal sign. For example, right, you're bringing the 6 over, subtracting. Do I need to flip the sign? I'm not multiplying or dividing by a negative, correct? So that it's all good. So y is less than 6. You don't need to find the intercepts because this is already very obvious that it's a horizontal line. So I'll say this, just when I get here, it's horizontal, dashed, true is, where is true region? Let's see if you're paying attention. It's less than, so below, right? Okay. Okay. So it's, if you sit down and you try these, you should be able to get this done. Okay. X-axis, y-axis. This is going through 0, 6, correct? So watch this. I'm going to go 2, 4, 6, 8, right? So every mark is worth 2. Let's just put a couple marks here. And look, my scale for the y-axis is consistently 2. See, I show that I'm going -2 here. And 0, 6 is right there. So we're going to make, let's see if you catch this. There's something wrong with it. It's solid. Oh boy, but it's easy to fix. Right? Right? Now it's dashed, right? So there you have it. True happens to be below again. And we shade, and it's everything below that line that would make it true. Okay. You think you can handle graphing? Is this easier? No test point required, right? Find your intercepts, rewrite graph, right? Okay, now we're going to go backwards. We're going to go from the graph to the inequality. writing the inequality given a graph. I would underline this or something. It's like a important subtopic. I'll give you the steps. Find slope. Remember that the slope is rise over run. And remember that if it goes up, it's positive, and if it goes down, it's negative. Secondly, find the y-intercept. Thirdly, determine true region. Fourth, is the line solid or dashed? And then write inequality I'll just say may vary, right? And that's just because it could be less than or equal to, it could be greater than or equal to. And so these are the steps, okay? And I just make up steps because a lot of students appreciate it. It doesn't mean that you necessarily have to do it in that order. But if you follow this order, you'll get it right every time. So now when you see the graph, it's going to kind of give it away already, but we'll still go through the motions, okay? So let me see here to help you out. We go -5 in every direction, we're fine. Yeah. So we're going to make a graph. And let's pretend you're given this graph, right? So you gotta trust me on this, I guess. So watch this. I'm gonna go X and Y. I'm gonna go 5 each direction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just make, if you use rulers, if your graph looks nice, you already found favor with me. So I'm a lot less, right? You use a ruler, you use nice scales, right? You won me over already. Okay, when I look at your graph, I'm going to be a lot less critical. Okay, so don't do the squiggly lines, you know, trying to make it look good. Use a ruler. Okay, so I'm going to ask you to put a point right here. And let's put another point going 3 points up on the y-axis. So that's going to be our, right? So it's basically -2, 0, 0, 3, okay? And now we're making our line. And I'm going to use a solid for this example. I'm going to shade this section here. And I will make a note here that regular shading has been applied. So let's say you're given a graph and I ask you, hey, write the inequality based on the graph. What does regular shading tell me? Which region did I shade? Yeah, you looked at your notes or you just remember, right? True, right? So that tells me that I can go ahead and say, mark that as true, because that is the important piece. Find the true region. For your inequality, find the true region, okay? And I'm kind of not following my steps now. Let's find a slope. How would you find your slope? The best is to find 2 points that are already given, right? Like the intercepts are probably the go-to. So if you highlight that and that, there's a rise and a run. So you went up and over, right? How many units did I rise? 1, 2, 3, right? And how many units am I running? 2. So I'm going to say for step 1 here, my slope is 3 over 2. Is it going to be positive or negative? I always, like if you had me for IPR, I would have said, don't worry about the sign at first. And then it's positive, right? It's going up from left to right. So it's just positive, leave it like that. If it had gone this way, and you find your rise and run, you just put a negative in front of it, and then you're good, right? No stress. Secondly, my y-intercept is right there. So it's 0, 2, and that tells me that B, which is really what I'm after, this is the point, and B is 2, right? They say the same thing. That's that. Thirdly, determine the true region. True is above. So I'll be using this one. Fourthly, is it solid or dashed? It's solid. So this transforms to this. And now I write my inequality. So I go y, I leave it blank for now. Slope is 3 over 2x. And it's a positive intercept. So you do that, and now we can just insert that inequality there, and voila, right? You're done. That's about as much French as I can do. Okay. So y is greater than or equal to that. So this is the, and you'll never have to rewrite it in standard form or anything like that. This is good enough. Okay. So that's that. Let's do one more. I will perhaps just use the booklet. Yeah. Do you think you can work for half an hour quietly? You can't? Because otherwise I'm going to keep going to systems. That's the alternative. Yeah. Go ahead. Can you? Well, I'll try it. So actually 2 to 4. Okay, I will do a couple with you, right? So that's why I'm going to use the booklet to as an example, okay? Then it's a little bit easier. So take your workbooks. I want to practice this skill right here, right now. This. So I'm going to show you a couple, and then there's more that you can practice on. Okay? You always seem surprised by homework. Did you not get any homework in IPR? What's that? I hope you did. Okay. Here. Okay, go over to page 3, please, where you see these graphs. Go to page 3. Okay, I will tell you this because otherwise you're going to be frustrated, so you have to listen. Unless I tell you otherwise, you assume regular shading. Okay? If it's not stated anywhere, you're like, okay, I'm assuming that the shaded region is the true region. Okay? So how about this? We do this. Assume regular shading. All of this will be posted. The answer key to every single one will be posted by the end of today. Okay, so you can go check. Of course, these are all missing arrowheads, X and Y, right? Like it goes without saying that those are things that you're supposed to have there. So I'm giving you, that's a disclaimer that sometimes these graphs do not have that. So let's write the inequality for this. This is true here. And I can tell true is below, right? But let's find the information we need. My slope is going to be positive. And is the intercept a good point to pick in this particular case? It's not. It's in between. Don't pick in between values. Is this a good point right here? The answer is yes, because it's going right through an intersection, right? So we know this point. So mark it and then scan the line until you cross again, which is right here. You see that? And if you're not sure, continue this one more time and see if you land on a specific point. If it's true, then you're good. That's the slope. If you try that same rise and run again and you're landing in between, then it's not it, right? Then you got to redo it. But it is 2 up, 1 over, right? So it's 2, 1. Rise is 2, run is 1. So it's 2 over 1, which is just 2. Sometimes we like to keep it like that when we're trying to graph, right? It's 2, 1, 2, 1. My y-intercept is 0, 5, so it's just 5. And you can skip some of the steps. I'm just making you think a little bit, right? True is below and it's solid. So I'm going to go less than or equal to 2x plus 5. Go ahead. I'll just make a note here. Okay, it's solid and true is below. Right, like that's how I got that inequality symbol. Right. Let me zoom in a little bit. Some of you are further back, right? So that's how you would have done one of those. And it's a diagonal line, so you expect to have y and x, right? Let's try this one. Okay. So we are given 2 points that are exactly, right? We are given exact coordinates, so that makes it easier. So you have a rise of 2 units and a run of 3. I will just warn you, check your scale. Sometimes one box is worth 2 units. You know what I mean? You have to look carefully. But in this case, I know everything. So it's 2 vertical and 3 horizontal, right? This is my rise and this is my run. And the line is dropping from left to right, so my slope is negative. So slope is 2 over 3 negative. I always make the negative float up. Okay. My y-intercept is given to me, that's negative 2. So now I can write it y negative 2 over 3x minus 2. Where is the true region? It's shaded in this case, so it's above, but it's dashed, right? So I'm going to go y is greater than, but not include the equal sign there. This is it. Okay, and I'll make a little arrow just saying that it's dashed. That's how I came up with that, dashed, and true is above. And we have two special cases there. So this is a vertical line. So this is a special case. It's a vertical line. So all you have to do is, when it's vertical, it's just going to be x. Sorry, you can't see that. Sorry, I apologize. Special case vertical line, x, and this is negative 2, 0, right? Negative 2, 0. That point right there. So we know we're going to have a negative 2 here. And what symbol am I going to put in there? It's solid, right? So it's going to have an equal sign. So if true is to the right, I will have to put down greater than or equal to. Okay. There. Greater than or equal to. True is here. Special case. In this case, it's a horizontal line. And if this is on your study sheet, you're laughing, right? You're not guessing, right? I would put a lot of the information I gave you today on my study sheet. Y, and this is the point 0, 4. So that means that there would be a 4 there, and true is below, so I have to go less than, not equal to, just less than. Okay, and that's how you go backwards from graph to inequality. 13, I'll let you do that, and I talked about it in the notes how to do this. Right, you have to plug each one of them in to the inequality and see if this statement is true. And I need you to try the back side. 4. Now listen carefully if you want to. What are you going to focus on, the true region or the shaded region? What's more important? The whole time we've been focusing on what? The true region. What does solution mean again? It is the true region. Okay, so don't let that throw you off. Okay, so true is the same thing as solution. Okay, so if you want to go to every single graph and scratch, I wouldn't scratch off solution. I would just put true right next to it. And so that's what you're focusing on for every single one of those. Okay? I don't know if you want to start with that and then do graphing. I need you to also be able to graph for Monday. Okay? Know how to graph your inequalities, and I will post that as well. Okay? So go ahead and graph and try these questions. Okay?